Hello, everyone. Welcome to this complete walkthrough of the WAEC 2025 Chemistry Theory questions. So in this video, I will guide you through each solution step by step to help you understand and improve your performance. Let's dive right into question one. The first question says, how many moles are there in 4.8 gram of ozone? Okay, and we're given the molar mass of oxygen to be 16. Oxygen is what makes ozone. So, first off, we would figure out what the formula for ozone is. So, ozone is oxygen 3. If one oxygen has the molar mass of 16, okay, ozone 3 would be 16 times 3, which is 48 gram per mole. Okay, and we know that for us to find the mole, which is what they are looking for, mole is equal to mass divided by molar mass. And our mass is 4.8. Our molar mass is 48. Okay, so 4.8 divided by 48 is 0.10 mole. So this is our answer. Now the next question says, write the formula for the following ions. So the first ion, we have hydrogen tetraoxosulfate 6 ion. So an easy way to be able to write this is we already know tetraoxosulfate 6 is written this way. This is the ion, okay? And hydrogen ion is written this way. So hydrogen tetraoxosulfate 6 ion together, when they bond, is going to give us hydrogen, then the SO4. So our overall charge is now going to be more like +1 -2, which is going to give us -1. So we don't need to write the 1. Okay, so we eliminate this one here. The other one is the answer. Now the next one is oxonitrate 1. The 1 there signifies the charge of the nitrogen. Okay. Now, oxo tells you the presence of oxygen. Okay, so this is more like oxygen and nitrogen. Okay, we see that nitrogen has a charge of +1. Okay, and oxygen normally has the charge of -2. So to properly write this, it would be NO, and the overall charge is more like -2 + 1, which is also going to give us a negative charge. Okay, so we just eliminate this, and this is our answer. Now, the next question says, name the following organic compounds. Okay, now these kind of compounds, it is best advisable to draw the full structure. Okay, so you don't just go and count the number of carbon and say, oh, because these carbons are 4, this is probably going to be a butane. So we see that the first carbon has 3 hydrogens, so we'll write it out. And the second carbon has just 1 hydrogen. The third carbon has just 1 hydrogen. And the last one has 3 hydrogens. Okay, so we see that carbon number 2 and 3 both are not completely bonded. It has to be tetra. Okay, the bonds has to be 4. Okay, so we have a double bond here. Now they are both completely bonded. So this tells us that there is an alkene group here. So since we have 4 carbons, we'll say but. Okay, and we see our functional group is in, right? It's a double bond, so it belongs to the in family, and it's in the second carbon number, so it's going to be put to in. Okay, and now the next question is this. If you want to draw out the structure, if this helps you to properly name, okay, so we have the first carbon has 3 hydrogens, the second has 2 hydrogens, and the third carbon has a carboxylic acid group. So this tells us it's a carboxylic acid. And since it's 3 carbons, it represents a prop. So this is now propanoic acid. Okay. Now the next question says, what does it mean to say an atom is electrically neutral? An atom is electrically neutral when the number of protons is equal to the number of electrons. Okay? So we know protons are positively charged and electrons are negatively charged. So it's more like saying a plus, um, adding a plus to a minus, it will just give you a zero. Okay? More like in mathematics, we see plus, plus minus, or plus and minus always end up giving you zero. So it's more like saying, for example, plus one minus one is the same thing as zero. Plus two minus two is the same thing as zero. So they are neutralizing each other. So we can say an atom is electrically neutral when it has an equal number of protons, which are positively charged particles, and electrons, which are negatively charged particles. Okay, so that the overall charge of the atom is zero. Okay, so this is a befitting answer for this. And now the next question says, write the electronic configuration of 12 magnesium. Now the 12 there represent the atomic number of magnesium. Okay, and we know in electronic configuration, the first energy level has a maximum of 2 electrons. Okay, and the second has a maximum of 8 electrons. So this 2 plus 8 is giving us 10. We are looking for magnesium. Magnesium is 12. So we have 2 left to complete its 12. So the third energy level is now going to have 2 electrons. It's supposed to have a maximum of 8, but if we're having 8, we're exceeding 12. So the remaining number of electrons we have is 2. So 282. This is the electronic configuration for magnesium. Now the next one is sodium. Sodium's atomic number is 11. Okay, but this is sodium ion. Okay, it's not just neutral sodium. Now, the sodium ion is sodium positive, and sodium positive means that sodium has already donated 1 electron. Okay, so it's more like saying in chemistry, in terms of um, electronic configuration or in terms of electron transfer and the rest, when you are losing, you are acquiring a positive sign. But when you are gaining, you are acquiring a negative sign. So this positive sign here means that sodium has lost or has donated 1 electron. So it's no longer 11, it's now 10. So the electronic configuration of this would be 2 and 8, which is equal to 10. Now the next one is for nitrogen. The atomic number for nitrogen is 7. Okay, but we have nitrogen 3 ion. Okay, so 3 negative. So that means that nitrogen has accepted 3 more to its 7. Okay, so it's now going to be 7, 8, 9, 10. So it's now 10 electrons that nitrogen is having. So it's also going to have the same configuration as the one above. Okay, so now the next question is, what is an acid salt? Okay, so we can say an acid salt is a salt formed, okay, when when the replaceable hydrogen ions in the acid is replaced only partially, partially, okay, by a metal or another positive group, or let's say an ammonium ion. Okay, so we can have an example here. For example, H2SO4 is reacting with sodium hydroxide, acid and base, to give us sodium HSO4 plus H2O. Now we see that the same H2SO4 we have here is the same salts that we are forming here. The salts that we form here is just having one of the hydrogen replaced by the metal. Okay, so that's just what the definition is explaining. Not all of the hydrogens are replaced, just partially replaced. Now, the next question says an element is represented as this, where X is the symbol of the element. What do letters A and B represent? Whenever elements are represented this way, with a superscript, the number at the top, and a subscript, the number at the bottom, the superscript is always the mass number. Okay, and the subscript is always the atomic number, or we can say the proton number or the electron number for a neutral atom. So that is what we have there. And the next question says, what separation method can be used to separate a mixture of sand and water? Sand and water, we can use filtration for this separation process. Sand and ion fillings, we can use magnetic separation, or we can say magnetism. Okay, magnetism or magnetic separation. Okay, and the next one is water and ethanol. We can do this by fractional distillation. Okay. Now the next question says, state the type of bonding that occurs in each of the following species. Now the first is magnesium. So magnesium bonding with itself is going to be metallic bonding because magnesium is already a metal. So a metal bonding with itself has to do with metallic. Okay, metallic bonding. Now the next is sodium and bromine, sodium bromide. Okay, so sodium is a very positive atom and bromine is very negative. So bonding between a positive charge and a negatively charged atom is going to give us ionic bonding. So that is what ionic is all about, between positive and negative atoms. So negatively charged particles. So we have ionic bonding. And the next is between phosphorus and hydrogen. Okay. So this is going to be covalent bonding. Okay. So now the next question says, arrange the following metals in order of increasing reactivity. Now, in terms of reactivity, metals are very reactive, but then the group 1 and 2 metals, okay, alkali metals and alkali earth metals, they are more reactive than the transition metals. So lead, zinc, um, silver, they are all transition metals. Okay, so metals we can see in group one, they are very much more reactive than group two, and group two are much more reactive than um, transition metals. So for us to properly arrange this, we would say silver first, okay, less than lead, less than zinc, less than magnesium, and less than sodium. Okay, now they said which of the following metals in above easily donates electron. So since sodium is the most reactive one there, it's the one that will act most as a metal. Okay, and because it will act so most as a metal, it's the one that will readily want to do the things that metals do, which is donating electrons. Okay, so this would be sodium. Now, the next question says, number two question says, explain briefly each of the following terms. We have functional group. Now, a functional group is an atom, a radical. Okay, a radical implies group of atoms. Okay, or bond, like alkanes and alkenes and alkynes. Okay, bond common to a homologous series, okay, and which determines, okay, the chemical properties of the series of organic compounds. So it's very important to include the chemical properties it's determining the chemical properties. Okay, so this is what makes functional group what they are. They determine the chemical properties of that particular homologous series they identify with. Okay, now primary alkanols. Primary al okay, primary alkanols. Okay, alkanols that have only one alkyl group attached to the carbon or to the carbon atom that carries the hydroxyl group, okay, which is the functional group. So they typically would have one alkyl group and the rest group attached to the carbon would be um, the functional group and hydrogens, okay? Now, complete the tables below. Now, the first one is hexanol. Okay, hexanol, we know it has six carbon atoms. Hexanol belongs to the alcohol family. So we can use the general formula for alcohols, CnH2n plus 1OH. Okay, so when we do that, we would have the formula C6, C6H13OH. Okay, and the functional group here is the OH functional group. Okay. Now, the next one is propyl butanoate. Propyl butanoate would be C7H14O2, and this is an ester. A functional group of ester is COO, or it can also be written as this, okay? And then the next one is ethene. Ethene is C2H4, and the functional group is double bond. So we'll write the double bond between two carbons, okay? So this one, the for general formula, we can use CnH2n. Okay, so the next question says, say the type of reaction illustrated in each of the following equations, okay? Now, the first one, we can see CnH2H4. Okay, this is an alkene. And then when we see it in the product, it's showing the same thing, and we are seeing the N here. This implies polymerization, and it is additional, okay, or addition polymerization. When we have a more and more and more number of alkene group, it usually involves alkenes. Now, the next one is combustion reaction, because combustion reaction is the reaction where an hydrocarbon bonds, which is presence of oxygen, to give us carbon dioxide or carbon monoxide and water. So we see our products here are carbon monoxide and water. This is what tells us this is a combustion reaction. Okay, and the last one is an oxidation reaction. Now, the both of them are involving oxygen, but the difference here is oxidation reaction just involves the addition of oxygen. Okay, it has its own definitions. Okay, so, but combustion, it involves saying in the product a carbon dioxide and water, or carbon monoxide and water being used. Okay. Oxidation also involves the loss of electrons, so it just depends. But in this case, we are talking about the addition of oxygen. Now, the next question says, take one use of the product in 2CII, okay, which is the polymerization reaction. One use of the product. So, what are polymers used for? We have polymers like polythene. Okay, so polymers are used in making plastics. Okay, so plastics could be bags or containers. Now, the next question is name one poisonous oxide of carbon. Carbon monoxide, CO. Okay, and the next question is name two strong inorganic acids. Okay, so in this kind of question, carbon acids, carbon and nitrogen acid or carboxylic acids, those ones are organic acids. These inorganic acids, they are the ones involving hydrogen that we commonly would use in um in base reaction. Okay, you also use organic, but these are the common ones we know that doesn't necessarily involve carbon and hydrogen and the functional group of carboxylic acid. So this one would be we have H2SO4, sulfuric acid. We also have nitric acid, HNO3. Okay, so you can also have hydrochloric acid. So these are the three most common um strong inorganic acids. So now the next question says, calculate the volume of this of 0.10 mole per dm cube potassium hydroxide required to neutralize 12.50 centimeters cube of 0.10 mole per dm cube of H2SO4. Now, in this situation, we need to write a balanced chemical equation. Now, our balanced chemical equation is going to be H2SO4 plus 2 potassium hydroxide to give us K2SO4 plus 2 moles of water. Okay, we see that based on this reaction, we would need one H2SO4, 1 mole of H2SO4 requires 2 mole of potassium hydroxide. Okay, we have established that. What else do we need? And we are also, what other information are we giving? We are giving, first off, the formula we can use to be able to solve this is concentration of acid times volume of acid divided by concentration of base times volume of base to give you number of mole of acid divided by number of mole of base. This is the formula we're going to use to solve this. Okay, now let us bring out our variables. The first variable is concentration of acid. Concentration of acid, based on the question, is this, okay, 0.10 mole per dm cube. Okay, and then the next thing, volume of acid. Volume of acid, are we giving volume of acid? Yes, which is 12.50 centimeters cube. Okay, now the next one is concentration of base. Concentration of base is equal to 0.10, and then volume of base is what we don't know. So that's what we're going to be calculating. Now, number of moles. Okay, before we get to the number of mole, if you notice something here, our concentration is in mole dm cube. Okay, and our volume is in centimeters cube. Now, dm cube and centimeters cube are both units for volume. So we have to stick with one unit for us to be able to solve adequately. Okay, we can end up making our answer for volume to be in centimeters cube, fine, but we'll have to convert this centimeters cube to dm cube. So everybody will be in uniform. Everything is going to be in uniform, okay? So we'll have a standard unit. So to do that, we should take notes that 1 decimeter cube is equal to 1000 is equal to 1000 centimeters cube. So converting this centimeters cube, our volume is actually going to be 0.00125 decimeters cube. Now everyone is on the same page. Okay, now number of mole of acid and number of mole of base. Number of mole of acid, are we given in the question? No, but we can actually find it because number of mole is equal to concentration of acid times volume of acid. So this would be concentration of acid is 0.10, okay, times volume of acid is 0.00125. Okay, so our number of mole of acid is going to be 0.00125. Okay. Okay. Our volume is 0.0125. Okay. So this is going to be our mole. Now, our number of mole for base We can find that by relating the balanced equation. So that is why we did this balanced equation. So based on the equation, if 1 mole of acid gives us 2 moles of base, okay, so therefore 0.00125 of acid will give us how many number of mole of base? So it's more like saying 1 gives us 2, so 0.00125 will give us how many? So we're going to cross multiply, and when we do that, a number of mole of base would now be 2 times 0.00125. Okay, and if we calculate this, we would get we'll get we'll get 0.0025, 0.0025 moles. Now we can now find our volume, which is what the question asked us initially. Okay, we can now find our volume. So fixing it into this general formula we had here, okay, fixing it into this general formula, we would now have that Ca, which is concentration of acid, 0.10 times volume of acid, which is 0.0125, okay, will be divided by concentration of base 0.10, okay, times volume of base, which is what we do not know, okay, VB, equal to number of mole of acid is 0.00125 divided by number of mole of base, which is 0.0025. Okay, so when we multiply these all through and cross multiply, we would get our volume, our VB, to be equal to 0. Our VB will be equal to 25 in centimeters cube. Okay. Okay. Now this is in centimeters cube, but we're not asked to convert our final answer. Okay. So, but in decimeter cube, since we converted, we're going to have 0.025 decimeters cube. Okay. So these are answer. Now the next question says define electrolysis. Now electrolysis is defined as the chemical decomposition, okay, or the breakdown of a compound, okay, in the molten state or in solution, okay, by the passage of electric current through it, or by passing electric current through it. So that's what electrolysis is. Now the next question says Explain the effect of concentration on the anion that is preferentially discharged in brine electrolysis. We know electrolysis of brine is concentrated sodium chloride solution. Okay, so in terms of preferential discharge in the anion, would say when the concentration, okay, of chloride ion is high, chloride ion are preferentially discharged. Okay, instead of the hydroxide ion. Okay, leading to chlorine gas being formed. Okay, so now if the solution is dilute, okay, the concentration of chloride ion is low. Okay, so hydroxide ion are now preferentially discharged. Okay, producing oxygen gas instead. So this is what happens. Now the next question says, consider the following elements. Okay, we have sodium, chlorine, calcium, and oxygen. Arrange the elements in increasing order of electronegativity. So electronegativity increases from left to right of the periodic table. So metals are totally very much least electronegative. So we have sodium first, less than calcium, less than oxygen, and less than chlorine. Now the next is step one use of each of the elements listed above. So sodium is used in street lighting. Okay. Chlorine. We know very commonly that chlorine is used in water purification, removal of microorganisms. And the next is calcium. Calcium can be used in cement manufacture or in the manufacture of cement, and oxygen useful in respiration. Okay. Now the next question says, when drops of compounds X are added to calcium oxide, compound Y is formed. Now Y reacts with ammonium chloride on heating, okay, to produce gas Z, which turns damp red litmus paper blue. Now, the first question we can ask ourselves to easily know what X, Y, and Z is to ask what turns damp red litmus paper blue? What test is that? Okay, and that would give us ammonia. So we have established that Y is ammonia. So in the test for ammonia, it is ammonia that turns that red litmus paper blue. So since we know that this is ammonia, it implies that something reacts with ammonium chloride to give us ammonia. Okay? And don't forget the X. So everything is just going to make sense together. So in the testing for ammonia, it is calcium hydroxide, okay, that will react to give us the ammonia. Now, they said the first one is a compound X is added to calcium oxide to form calcium hydroxide. Okay, so calcium hydroxide is basic, and calcium oxide is obviously already basic, so it is mixing with water. Okay, so write an equation for the reaction of X with calcium oxide. So that is water with calcium oxide. So we would have our calcium oxide plus H2O to give us calcium OH2. Okay, let me properly write this. Calcium OH2. Okay, and this is already a balanced equation. Now the next one is calcium hydroxide plus ammonium chloride to give us calcium chloride plus ammonia plus H2O. Now, this is not a balanced equation. We say our calcium is balanced, okay? Our number of nitrogen is also balanced. Our number of oxygen in reactant is 2, and oxygen in the product is just 1. So we would have to make the product to be 2. And then our hydrogen is now affected. Hydrogen in the reactant is 6, and hydrogen in the product is, we have 4 here and 3 here, which is 7. Okay, so to properly balance this, we put 2 moles here. Okay, and now our hydrogen in the reactant is now 2 here and then 8 here, and in the product is 4 plus 3. And since we are adding 2 here, our nitrogen is also affected, so we have to add another 2 here in the product so that our nitrogen will be balanced, and as well, hydrogen is also balanced. The next question says, write a balanced equation for the reaction of aluminium with oxygen. We have aluminium like this, and if it is reacting with oxygen, when aluminium bonds with oxygen, it gives us this, because aluminium will take the valency of oxygen, which is 2. Oxygen will take the valency of aluminium, which is 3. So the next thing for us to do is to actually balance this. So balancing this, we have to make aluminium equal here by adding 2 here. Okay. And then oxygen will have to be balanced as well. So to balance our oxygen is to make 2 equal to 3. So an easy way to do that is by imputing 3 here and then imputing 2 here, such that it's now 6 and 6. But that's the closest multiple of 2 and 3. Now, aluminium is now 4 in the product, so we have to input 4 here. So this is a balanced equation. And then the next question says, what mass of oxygen would react with 9 gram of aluminium? Okay, and we are giving the molar mass. We already saw the balanced equation, and we see that we need 4 moles of aluminium, okay, to react with 3 moles of oxygen. So it's more like 4:3. Now, to find the mass of oxygen is equal to oxygen is equals to number of mole times molar mass. So what is the number of molar? What's the molar mass of oxygen? Molar mass of oxygen is equal to 32 because we are dealing with oxygen molecule here, excluding the moles, which is the coefficient, okay? But we don't know the number of mole of oxygen. We would know the number of mole of oxygen by calculating that of aluminium and then relating to the balanced equation. Okay, so the number of mole of aluminium is equal to 9 divided by 27. Okay, because 9 is the mass given to us there, and 27 is the molar mass. So 9 divided by 27, it will give us 0.033 moles. Okay, so now going back to the balanced equation, they said 4 aluminium would require 3 moles of oxygen. So therefore, 0.33 aluminium will give us how many oxygen? So to get the mole of oxygen, we would say it's now going to be the number of moles of oxygen would be 0.33 times 3 divided by 4. Okay, all of this will give us 0.25 moles. So now we can now fix into this equation here. Okay, so our mass of oxygen is now equal to number of moles 0.25 times molar mass 32, which will give us 8 grams. Now the next question says name element added to natural rubber to improve its quality. That element is sulfur. Now the next question says what is this proportionation reaction? Okay, so this proportionation reaction is a reaction where a substance is both oxidized and reduced. Okay? Now the next question says give the oxidation state of phosphorus in each of the following species. Okay? Now we have phosphorus we do not know, plus the oxidation state of oxygen is -2, plus that of chlorine is -1. So we have 3 chlorines. So it's going to be -1 times 3, all equal to 0 because it's a neutral compound. So from here we have phosphorus -2 minus 3 equal to 0. So phosphorus is now phosphorus -5 equal to 0. So the oxidation state of phosphorus is equal to +5. Always include your positive or negative sign. Now the next one is phosphorus and hydrogen. So we have phosphorus plus hydrogen is positive, right? So +1 times 3 all equal to 0. So it's now going to be phosphorus plus 3 equal to 0. So the oxidation state of phosphorus is equal to -3. Okay. Now the next one is this. It's only phosphorus here. So it's not relating the oxidation state of any other person, and it's a neutral atom. So this is going to give us 0. Now this next one is we have hydrogen, which is plus 1 times 2, okay, plus phosphorus plus oxygen, which is minus 2 oxidation state, um, times 3, all equal to 0. Now this is now going to be 2 plus phosphorus minus 6 equal to 0. Okay, so phosphorus is now going to be minus 2 plus 6, which is equal to 4 plus 4. Okay, say Dalton's law of partial pressure. So Dalton's law of partial pressure states that the total pressure exerted, okay, by a mixture of gases which do not react is chemically which do not react chemically which do not react chemically is equal to the sum of the individual partial pressures of the gases in the mixture. Okay, so the next question says a cylinder contains 2 moles of oxygen molecule, 3 moles of carbon dioxide, and 5 moles of nitrogen molecule at a particular temperature. So if the pressure of the cylinder is 210 newtons per meter square, calculate the partial pressure of oxygen molecule and nitrogen molecule. Okay, so for us to be able to find this, we'll first find the total moles. Okay, so the total moles is going to be 2 plus 3 plus 5, which is giving us 10. So the partial pressure of oxygen would be that of oxygen as given in the question here. Okay, is 2. So it will be 2 divided by 10 times the pressure of the cylinder, okay, which will give us 42 newtons per meter square, okay, and then the partial pressure of nitrogen molecule, okay, is going to be that of nitrogen is 5 moles, okay, so it's going to be 5 divided by 10 times 210, which would give us 105 newtons per meter square. So that's our answer for this question. Now the next question says, define the term concentration of a solution. Okay, so the concentration of a solution is the amount of a solute in a given volume of the solution. Okay, so now the next question says calculate the mass concentration of 0.10 mole per dm cube of sodium triisocarbonate. Okay, now this is the molar mass of sodium triisocarbonate. Now mass concentration, okay, is given as molar concentration or molarity times molar mass. Okay, so our molar concentration is the 0.10 moles, okay, moles per dm cube, and our molar mass is the 106. So when we multiply this, we have 10.6 gram per dm cube. Now the next question is describe our 1 dm cube solution of 0.10 mole per dm cube sodium triisocarbonate could be prepared. Okay, how it could be prepared. Now, if you look at this question, it's actually relating with the previous one we just did. Okay, because we're dealing with 0.10 mole per dm cube, just as that's the molar concentration we saw here. Okay, so we'll be making use of the details in the previous question. Okay, so to prepare this, we would say weigh 10.6 gram, okay, of sodium triisocarbonate and dissolve it in a small amount of distilled water. Okay, in a beaker. Now the next thing to do is to transfer the solution into a 1 dm cube flask. Okay, and then we'll rinse the beaker and the funnel used to measure. Okay, and then we add distilled water up to the marked parts. Okay, that's the marked part of the volumetric flask. Okay, we add the stopper at the top. Okay, and then we would shake properly, or we shake well to mix. So this is how we can prepare the solution. Now the next question says, state two physical properties of each of the following substances. Physical properties. So now the first one is chlorine. One physical property entails the properties we can see. Okay, so we can talk about the smell, the color, the those obvious properties. Okay, and so Chlorine is greenish. Okay, it's a greenish gas. And another thing about its smell, it has a shocking smell. Now, the next one is hydrogen chloride. Hydrogen chloride is a colorless gas. Okay, and about its smell, it has a pungent smell. Okay, so it said states what would be observed when burning splint of hydrogen is introduced into a gas jar containing chlorine. Okay, what would be observed is explosive reaction. So this is the preparation of hydrochloric acid with white fumes. If you have opened up a concentrated hydrochloric acid before, you would understand or you would recognize those white fumes we talk about here. So HCl is formed. Now, the next question says, consider the following gases. We have this carbon dioxide, HCl, and methane. Okay, so the question is, which of the gases could be used to perform the fountain experiment? Okay, the fountain experiment will be HCl. Okay, and which of them can be used as a domestic fuel? That will be the hydrocarbon, which is methane. Now, the next question says, give reasons for each of the stated answers above. So, the reason why HCl is used in the fountain experiment, that is what we'll be writing here. Because it is highly soluble. Okay. Soluble in water. Okay. And the reason why um methane is used as a domestic fuel is because it burns easily with heat. Okay. So the next question says, state one industrial use of hydrogen chloride gas. Okay. So it is used in the manufacture of hydrochloric acid. Okay. And the next question says, when air reacts with red hot coke, a fuel forms. So name the fuel. Okay. We know hot coke has to do with carbon content. Okay, so the fuel that will be formed here is called the producer gas. Okay, so the next question is, mention the constituent gas of the fuel. So one is carbon monoxide and the other is nitrogen molecule. Okay, so now the next question says, give the reason why the gases mentioned in 5AII would diffuse at same rate. So it would diffuse same rate Okay, due to same molar mass. Okay, because if you check the molar mass of um carbon monoxide, that's of carbon, molar mass of carbon is 12, molar mass of oxygen is 16, 12 plus 16 is 28. Okay, the molar mass of nitrogen is 14. And if we have dealing with two nitrogens, that would be 14 plus 14, also 28. So we can see that they both have the same molar mass. So they would diffuse at same rate. Okay, they have same weight. Now, which of the gases mentioned in 5AII is less reactive? So the less reactive one is carbon monoxide. Okay. And the next question is give the reason for poor reactivity of the gas mentioned in previously. Okay. So the reason is that it is a stable molecule. Okay. More stable than the other. Now the next question says write an equation for the reaction between sodium and water. So we have sodium reacting with water. This would give, since sodium is a metal, when metal reacts with water, they tend to give us base. Always take note of that. They give us base and hydrogen gas. So the base that can be formed from this is sodium hydroxide plus hydrogen gas. Now the next thing to look out for is this equation balanced? It's not balanced. So to balance this, okay, our sodium is balanced, our oxygen is balanced for now, so we have to balance the number of hydrogen. Okay, so to properly balance the number of hydrogen, we'll give the reactant two more, and now we have um 4 and we have 3 in the product. Okay, so we also still need more adjustment. Now we have 4 in the reactant and also 4 in the product. But now sodium is already influenced again, so we have to make sodium in the reactant also balanced. So now our reaction is looking balanced. Okay, now the next is write the equation for the main reaction of iron 3 oxide in the blast furnace. Okay, so this is iron 3 oxide, okay, iron 2, oxygen 3. So in the blast furnace, this is the balanced equation. Okay. Now the next question says, explain briefly why the temperature in the blast furnace decreases from bottom to top. So we would say the temperature decreases from bottom to top of the blast furnace. Okay, because hot air is blown, is blown it, is blown in at the base. Okay, and this base is where combustion reactions release a large amount of heat. Okay, so as the hot gas um rise, heat is used up Okay, so the temperature would fall towards the top. Okay, so as the hot gas rises, okay, heat is used up and temperature falls gradually towards the top. Okay, so that's our answer. Now the next question says, the table below shows the products of the destructive distillation of coal and their uses. So to complete this, manufacture of fertilizers. Okay, so the product that would be useful in this is ammonia. Okay, now coal tar, the use of coal tar is in road surfacing. The production of water gas, that would be coke. And coal gas is used as fuel. Okay. Now mention one industrial process in each of the following compounds used. So we have aluminium hydroxide. Now the first one, the industrial process, it is useful in water treatment. Okay, and the next one, alum, it's used in water purification. Okay, and this last one, it is used in aluminium extraction. In aluminium extraction process. Okay. Now the next question says, state the function of each compound in 5DI in the industrial processes. Okay, so for the first one, aluminium hydroxide. Okay, the function is it serves as flocculant. Okay, pardon me. Okay, and the next is alum, useful in coagulation. And the next one is the cryolite. Okay, the cryolite is this last compound. So rather than saying the cryolite, okay, the last one is okay, it lowers melting points. Now the next question says name the compound. Okay, so we know that in naming this kind of compounds, we start with the positively charged parts. So this would be potassium, okay, aluminium, sulfate. It's as easy as that. Okay, so that brings us to the end of this section. Bye bye.